हरिः कन्ना।
So I just want to visually compare the NO2 values measured in London versus Paris. How can I do that? So I can do this, I can do that comparison using scatter plots. So on x-axis, I'll take it as a station London. On y-axis, I will take it as station Paris. And we will do that. For that, I have to consider a specific plot. So this time we will go for the scatter plot. So let's get into the action. So want to compare, want to visually compare the NO2 values measured in London versus Paris. Okay, so to do that, we will take the data frame again, AQ data frame, and this time I'll take the plot as usual. But again, inside the plot, we have a lot of other plots. So let me click dot and tab. Here are the different plots: bar, box, density, histogram, line, pie, and scatter. So let me click on scatter, and you can go with the default one. Let's see what default one we will give. If not, then we'll go for the actual one. So default one is saying some arguments, the positional arguments are missing, so it doesn't have a default values. So the main positional arguments are missing, that's x and y, that I'm gonna provide now first. So what the first positional argument is x, and what value I want to give from here. So I want it the London. I will put London in x-axis. So I will take station London and I'll paste it here. Yep. Then y-axis. So let me go for the y-axis. Y-axis I will go with the station Paris. So let me copy this station Paris and paste it here. So that's it. These are the minimum positional arguments. In addition to, if you want to provide anything else, you can provide. So here, let me give this much. This is more than enough. And let me say execute and see what's going to happen. And here is your graph. So station London and then station Paris. Okay. So this is how the air index is changing. So what I'm going to do is I will give alpha value 0.5 so that we can have a more clarity in labeling. So let me scroll down. We have taken the two labels. One is X label, that's X-axis station London, and Y label, that's a station Paris. And let me take alpha equals to 0.5 and execute again, and here is that you have clear cut distinction between, okay, alpha. Yes, you can see that clearly the scatter plot, and it will give you the exact relation between the, like, or how the values, NO2 values or air quality value from London and Paris are matching. So how can they be compared? So that's what it tells. Okay. Apart from the default line plot, when using the plot function, a number of alternatives are available so to plot data. So here you can see that let's use some standard Python to get an overview of available plot methods. To do that, so what I can do is I have to mention the method name, and then let me take some of the various methods that are available for me. Okay, so take a list and method name. Now let me write for loop for method name and in membership operator, and it's in my directory, so it's air quality df dot plot. So if not, method name dot starts with so let me execute this, and here are the methods that are available. Of course, we can see these methods directly, but these methods are specifically applicable to this data frame. Or else the another way of looking at the same thing is air quality data f, and let me go for the plot, and after that, that's it. You see, area bar h box density hexa bin xbin histogram kde line pi and scatter, and you have to give information. Okay, so what all information you have to provide? So pi requires either y column or subplots are true. So let me take this, and y column. Okay, so array y label is station anti-verb, access y label Paris. Let's take any one. So let me take y equals to, I'll go with the London again. Anti-verb, we don't have enough data. Okay, okay, and let me execute this. See, this is what a y label station London, and data type is object, and total subplots is true. And okay, you got okay, this is huge amount of data. This is actually wrong uh, way of using. Pi can be used for this, but still I just used, just want to show you, but you got a weird diagram, a weirdo. That's fine, it's not an issue. Okay, so that's how we see what all methods are available. So in many development environments as well as IPython and Jupyter Notebook, use the tab button to get an overview of the available methods. Okay, for example, this is what we did here. Let me show, I'll do it again one more time. So AQ, our data frame, and plot, then tab. Here are all the methods which are available. So that's what I'm saying. So if I just want to make a box one, no box, I'll go with the line one. Okay, just execute it, and here are the all. So if you specifically want, you can attach respective columns. Okay, So we can even make a box plot. So one of the options in that, let me take this one again, paste it here, and let me remove this and click on tab. So you can see the box here, the fourth option, which refers to a box plot. So the box method is applicable on the air quality example, this air quality data, also on this AQDF data frame also. Let me enter, let me click on this and just execute it and see what's going to happen. And this is your box plot. This is your box plot. And you need to know some amount of statistics to understand this box plot. You have whiskers, you have a center part, and you have the box, you have the limits here. What all are these things? We will discuss everything in detail in our statistics course, intuitive statistics for you course, in further sessions. You don't need to worry much about that. I will see you there again. Okay, so that's so you can explore more if you want. So I'll leave it here. So let me say tab. So if you want to go for the histogram, you can go for the histogram. Let me execute it, and here is the data of all. You can see the histogram of all. If you specifically want histogram of London, so let me copy the London from somewhere. Let me take it from here. Station London. Yep. Selection bracket, and I'm going for the histogram. And here is your histogram only for London. Okay, so the value, okay, this is not normally distributed. That's fine. The frequency, so it has taken by default the 20, 40, 60. So this is how it came. So for the other one, let me check for the Paris. What could be the distribution? These are all exploratory data analysis what we are doing. Oh, this is also by and large similar. By and large similar, but not same. There is a difference, huge difference. Let's get into the other one. Let me copy that. Yeah, station Antwerp, and paste it here and just execute it. And here is that. This is another one. Oh, this is absolutely different. You can see the clear cut outlier here for this Antwerp. Oh, it's too much. This is far better. Here you can see the clear cut outlier. So that's okay.